Thank you for choosing American Pest CEUs.
Hi, I'm Sean Reeves with American Pest CEUs. I've been in the pest management industry since 1999. I'm an associate certified entomologist, and I'll be your instructor for today's course. Today's course was compiled by Jack Launius, who has served in the pest management industry since 1990. Characteristics of herbicides in vegetation management. Herbicides are essential tools in controlling unwanted plant species, commonly referred to as weeds. Weeds can be hazardous along rights-of-way, impacting safety, infrastructure maintenance, and local ecosystems. These areas often encompass roadways, utility corridors, and other public spaces where vegetation management is necessary. Effective weed management in these settings can prevent reduced visibility, damage to infrastructure, and disruptions to the ecosystem. Moreover, weeds in these spaces may be considered invasive, detrimental to other plants, or a threat to human and animal health. To develop effective weed management programs, professionals employ herbicides alongside other vegetation control methods. This section outlines the critical characteristics, terminology, and functions of various herbicides used in right-of-way vegetation control. Key herbicide terminology and concepts. Understanding herbicides requires familiarity with various terminologies and concepts that help professionals choose the right product for specific applications. Here are some key terms to consider. Absorption method. This refers to whether the herbicide is absorbed through leaves, foliar, or roots, soil. When it comes to activity type, herbicides can be contact or systemic in their action. Looking at target plants, they can be selective, targeting specific plants, or non-selective, affecting all plants. When we look at mode of action, this describes how the herbicide disrupts the plant's internal processes. Active ingredient, also known as AI, the chemical component in a herbicide responsible for its weed-killing properties. It is essential to review the AI when selecting a herbicide, as different AIs have varying effectiveness on different types of weeds. Formulation refers to the specific mixture of active ingredients and inert substances in a herbicide product. Common formulations include emulsifiable concentrates, granules, and wettable powders. Each formulation has different properties regarding application methods, ease of handling, and efficacy. Label instructions. The herbicide label provides crucial information, including application rates, timing, recommended plant species, and safety precautions. Adhering to label instructions is vital for effective use and regulatory compliance. You'll hear regularly in the pesticide industry that the label is the law and it should be followed at all times. Weed life cycle. Weeds can be classified based on their life cycles, annual, biennial, or perennial. This classification influences herbicide selection, as timing and application methods may differ depending on the weed type. When it comes to herbicides, you always have to be aware of herbicide resistance. A growing concern in weed management, herbicide resistance occurs when certain weed populations evolve to survive applications of specific herbicides. Understanding the mechanisms of resistance is critical for developing effective management strategies. Environmental persistence. This refers to how long a herbicide remains active in the environment. The persistence of herbicides can affect subsequent plant growth and the overall ecosystem, impacting the choice of herbicides for different situations. Growth, phases, and stages. Effective weed management considers these factors, choosing herbicides based on specific plant types, the targeted growth stage, and environmental requirements. Types of absorption. Foliar versus root absorbed. Herbicides can be categorized based on their absorption methods, primarily as foliar absorbed or root absorbed. Foliar absorbed herbicides. Foliage-absorbed herbicides, also known as post-emergent herbicides, target plants after they have emerged from the soil. These herbicides are sprayed directly onto leaves and absorbed through the plant surface. Commonly used foliar-absorbed herbicides include 2,4-D, a widely used herbicide for controlling broadleaf weeds, especially in turf and crop areas. Diquat, a fast-acting contact herbicide effective on many annual and perennial weeds. Glyphosate, a systemic herbicide used to control a wide range of weeds and grasses, highly effective when applied to actively growing plants. Phosamine, crenite, a systemic herbicide often used for controlling woody plants and brush, and tricloper garland, effective for controlling woody plants and some herbaceous plants, especially in forested areas. Foliar-absorbed herbicides. Foliar-absorbed herbicides are applied to the leaves of plants where they are absorbed and translocated throughout the plant. Understanding how these herbicides work can help practitioners effectively control target weeds. Mechanism of action. Once absorbed, foliar herbicides move through the vascular system of the plant. They may disrupt various metabolic processes leading to plant death. For instance, glyphosate inhibits the shikimic acid pathway, which is essential for producing amino acids in plants, effectively starving the plant of necessary nutrients. Application timing. The timing of application is crucial for foliar herbicides. Applying them when the target plants are actively growing ensures optimal absorption and efficacy. For example, applications during flowering or early fruiting stages may be less effective. Weather conditions. Environmental conditions significantly impact the performance of foliar herbicides. High humidity and temperatures within the recommended range can enhance absorption, while excessive rain immediately after application can wash away the herbicide, reducing its effectiveness. Root-absorbed herbicides. Root-absorbed herbicides, or pre-emergent herbicides, are applied to the soil and absorbed through the plant roots. They work by preventing weed seeds from germinating or establishing. Examples include Bromacil hyvar, a residual herbicide effective for controlling various annual and perennial weeds. Diuron, effective for controlling broadleaf weeds and some grasses in industrial sites and rights-of-way. Arizalin surflon, a pre-emergent herbicide primarily used in landscape maintenance. Tibuthurion spike, often used in areas requiring long-term control of brush and weed populations. Annual grasses, root-absorbed herbicides variables. Soil mobility. The effectiveness of root-absorbed herbicides depends on their mobility in the soil. Some products are designed to stay close to the soil surface, targeting germinating seeds, while others may leach deeper into the soil profile. Persistence. The persistence of these herbicides is critical in managing weed populations over time. Products with long-term residual activity can suppress multiple weed generations, but this must be balanced with the potential impact on desired plant species. Application techniques. Proper application techniques, including soil incorporation, are vital for ensuring that root-absorbed herbicides reach the target zone in the soil. Techniques such as banding or spot applications can help minimize non-target exposure. Dual-absorbed herbicides. Some herbicides can be absorbed through both foliage and roots, increasing their application versatility. Clopyralid transline, primarily used for controlling broadleaf weeds, especially in pastures and roadsides. Clopyralid transline, primarily used for controlling broadleaf weeds, especially in pastures and roadsides. Hexazenone felpar, effective against a range of weeds, particularly in forest management. Imazapyr arsenal, a systemic herbicide effective against many woody and herbaceous plants. Picloram torton, used to control tough weeds and woody species, particularly in non-crop areas. Sulfametron oust, commonly used in managed forest and rights-of-way. Selective versus non-selective herbicides. Herbicides can also be categorized as selective or non-selective based on their target plants. Understanding the difference between selective and non-selective herbicides is crucial for effective vegetation management. Selective herbicides are designed to target specific plant types while leaving others unaffected. For example, certain broadleaf herbicides target auxin receptors that are more prevalent in broadleaf plants than in grasses, allowing them to control broadleaf weeds without harming grass species. Examples of selective herbicides include 2,4-D targets broadleaf plants while leaving grasses relatively unharmed. Dicamba targets broadleaf weeds while leaving grasses unharmed, often used in conjunction with glyphosate-resistant crops. Methylfuron methyl escort, selective for many broadleaf weeds, especially in grass crops. Tricloper, effective against woody plants, particularly in mixed vegetation areas. Application considerations. Proper timing and application techniques are essential to ensure selective herbicides effectively control target species without harming nearby desirable vegetation. For instance, late spring applications may effectively control certain annual broadleaf weeds before they set seed. When we look at non-selective herbicides, they are going to be particularly useful in areas where establishing new vegetation is the goal, as they kill all plant material present. Strategic use. Non-selective herbicides are often employed in non-crop areas, such as along roadsides, industrial sites, and construction zones. Proper use involves understanding the surrounding vegetation and timing applications to minimize collateral damage. Examples include glyphosate, known for its effectiveness against a wide variety of weeds, including grasses and broadleaf species. Bromacil, useful for total vegetation control in non-crop areas. Tibuthiurin, often applied in forestry and rights-of-way for broad-spectrum control. And paraquat, a contact herbicide that provides rapid control of emerging weeds. So we would be amiss if we didn't talk a little bit more about glyphosate. Glyphosate has been in the news a lot here lately. You've probably heard a lot of things about lawsuits and things like that when it comes to products like Roundup. Glyphosate is an herbicide commonly used to kill certain plants and grasses. It also manages how plants grow, gets crops ready for harvest, and ripens fruit. It's classified as a non-selective herbicide. This means it kills most plants to which it's applied. It works by stopping plants from creating certain types of proteins that enable growth. Especially for purposes of this course, we want to talk about glyphosate herbicide uses. Glyphosate has many different uses. It's used everywhere from home gardens to pig agriculture. That leads us to another important question I think we need to ask in today's environment. Does glyphosate cause cancer? The reason why I'm including this is because everywhere you go, if you turn on the TV or the radio, you hear about products like Roundup and how they contain glyphosate and how it can cause cancer. You even see all these lawsuits and different things. So I feel like in a lot of pesticide applicators' minds, anybody putting out herbicides or pesticides, they're concerned about these products and their ability to cause cancer. So I wanted to land the plane on something by saying the Environmental Protection Agency, the EPA, in the U.S. says that glyphosate is not likely to cause cancer in humans. I think that's a big deal. I feel like a lot of people have this major concern, and what you see on TV is almost reality. So you're thinking, if I'm putting this product out, there's a good chance if it contacts my body or if I'm coming into contact with it, however, I could get cancer. The reality is, according to the EPA, there is a concern about other ingredients in Roundup as they may be more toxic than glyphosate. These other chemicals are not the active ingredients in Roundup, so they are rarely the focus of regulatory health risk assessments. One study found that Roundup was among the most toxic of the herbicides and insecticides tested. Think about what we're saying here. The reality is that when you look at a product like Roundup or anything that contains glyphosate, the EPA says it's not likely to cause cancer. At the same point in time, you will see studies that show that these types of products can be among the most toxic of herbicides and insecticides tested. The point being made here is you need to follow the label and you need to wear the correct PPE. If you're following the label on products and you're wearing the correct PPE, the chances of you being exposed to these products is very, very low. There's a reason why so much time, effort, and research goes into making a label and making sure you're protected from a product. If we don't do our due diligence and wear the correct PPE and follow the label, then definitely we're putting ourselves at risk for exposure, and we're also putting the environment around us at risk. So make sure to always follow the label, which is the federal law, and make sure you wear the correct PPE for your own protection so you don't have to worry as much about what the product might do. Just don't let yourself become exposed to it, and then you're not going to have to worry as much about the toxicity of the product. Translocated herbicides do move. They move into the xylem, which is mobile herbicides, move up into the plant, and into the phloem, mobile herbicides move up and down in the plant. Contact herbicides. Contact herbicides target only the parts of the plant with which they come into contact with. These products are effective on smaller or annual plants, but may be less effective against perennials since they may only kill the above-ground portions without affecting the roots. Examples of contact herbicides include glufosinate, phenol, a contact herbicide that acts quickly, causing rapid plant desiccation, paraquat, another fast-acting contact herbicide effective against many annual weeds, diquat, reward, a contact herbicide effective against a variety of annual weeds. Application strategies. To maximize effectiveness, applications should be made under optimal environmental conditions, ensuring thorough coverage of the target plants. This is especially important for dense infestations where complete leaf coverage is necessary. Let's look at systemic herbicides. Systemic herbicides are absorbed and translocated throughout the entire plant, reaching roots and other critical growth areas. This characteristic makes them particularly effective for perennial weeds as they ensure the herbicide reaches all parts of the plant. This ability allows them to kill not only the above-ground parts, but also the roots, preventing regrowth. Examples of systemic herbicides include 2,4-D, often used for broadleaf weed control. It is absorbed by foliage and translocated within the plant. Glyphosate, a non-selective systemic herbicide that works by inhibiting essential metabolic pathways. Imazapyr, Arsenal, a systemic herbicide that is effective against many woody and herbaceous plants. Tricloper, Garland, particularly effective against woody plants and vines. Timing of application. Systemic herbicides are best applied during active growth periods when the plant is most capable of absorbing and translocating the herbicide. Applications made during flowering or fruiting stages may be less effective as plants allocate resources differently during these periods. This makes it imperative as a pesticide applicator that you understand the growth seasons for the weeds and plants in your area. If you don't understand the growth seasons, you're not going to be able to hit them in the right stage. So make sure you look at your climate zone, look at the growth seasons, and understand when the best time to hit these plants and be most effective in controlling them is. Persistent versus non-persistent herbicides. Herbicide persistence refers to the duration a product remains active in the environment, influencing its application in various settings. Persistent herbicides. Persistent herbicides provide long-lasting weed control, which is advantageous in areas where frequent reapplication is not feasible. However, their persistence can hinder the establishment of desirable plants in reseeding efforts. Examples of persistent herbicides include Bromacil hyvar, known for its long residual activity in soil, providing extended weed control. Diuron, often used for controlling broadleaf weeds and grasses, remaining effective for extended periods. Imazapyr, arsenal, provides long-term control of various woody and herbaceous plants. Tebuthioron, spike, effective for long-term management of unwanted vegetation. Non-persistent herbicides. Non-persistent herbicides break down quickly, making them more suitable for short-term weed control without long-lasting effects on the soil. Examples include glyphosate, a widely used non-selective herbicide that degrades quickly in the environment, making it suitable for annual weed control. Phosamine, krenite, non-persistent, allowing for replanting soon after application. Tricloper, garland, primarily used for controlling woody plants with minimal residual soil activity. Classification by herbicide mode of action. Herbicides can be classified based on their mode of action, which defines how they affect plant physiology. Let's take a look at some modes of action. An example: amino acid synthesis inhibitors, imazethapyr, glyphosate, mode of action, lipid synthesis inhibitors, cyclohexanidiones, mode of action, seedling growth inhibitors, pendimethalin, allichlor, mode of action, photosynthesis inhibitors, atrazine, metribuzin, mode of action, cell membrane disruptors, example would be paraquat, mode of action, growth regulators, example would be 2,4-D, 2,4,5-T, dicamba. Mode of action, pigment synthesis inhibitor, an example would be bromoxynil. Growth regulators. Growth regulator herbicides mimic naturally occurring plant hormones, auxins, but at much higher rates, causing uncontrolled growth that disrupts the plant's vascular system. These herbicides are translocated throughout the plant, leading to cell damage and eventual death. Products like 2,4-D dicamba and tricloper fall into this category, primarily targeting broadleaf plants. Growth regulator herbicides, usually applied to foliage, but can have residual soil activity. Translocated, systemic, generally affects broadleaf plants, but grasses can be injured too. Characteristics. They cause growth abnormalities, such as leaf twisting and epinosty. Many growth regulators are persistent, with some classified as restricted use pesticides, e.g. picloram. Available in various formulations for different application methods, including emulsifiable concentrates and water-soluble salts. As you can see in this image, in the upper left-hand corner, we're looking at callus tissue formation. In the upper right corner, we're looking at leaf cupping. In the bottom left corner, we're looking at onion leafing. And in the bottom right corner, we're looking at fused race roots. Amino acid synthesis inhibitors. These herbicides block amino acid synthesis within plants, preventing the production of essential proteins necessary for growth. They are often used for selective control, targeting specific plant species while allowing others to remain unharmed. Products like glyphosate, chlorsulfuron, Tilar, and sulfomaturin, oust, work by preventing amino acid formation, leading to plant death over time. Here's a chart on amino acid synthesis inhibitors, ALS inhibitors. We're going to show the family, the common name, and the trade name. Family, imidazolinones, common name, imidazopyr, trade names, Arsenal, Chopper, Stalker. Family, sulfonylurea, common name, metsulfuron, trade names, Escort. Family, sulfonylurea, common name, sulfometron, trade name, Oust. These herbicides inhibit amino acid synthesis, which is necessary for the formation of plant proteins. Amino acid synthesis inhibitors often takes days to weeks to see damage. Grasses, stunning, purple tint. With broadleaves, you'll see purpling or reddening of veins, meristem necrosis. Glyphosate, you'll see yellowing followed by death. Characteristics: non-persistent, with glyphosate being one of the most widely used non-selective herbicides. Residual effects can occur, particularly with sulfometron and imidazopyr, which effectively control broadleaf weeds while minimally impacting grasses. Photosynthesis inhibitors. Photosynthesis inhibitors, such as diuron and bromacil, disrupt the photosynthetic process in plants. By blocking the conversion of light energy into chemical energy, these herbicides prevent plants from producing sugars, leading to starvation and eventual death. These herbicides are often persistent, providing residual weed control as they remain active in the soil. Let's look at photosynthesis inhibitors. We're going to talk about the family, the common name, and the trade name of each. Our first family of photosynthesis inhibitors is going to be family name of triazine, common name atrazine, trade name is going to be Atrax. Second, our family is going to be triazine, common name sympazine, trade name Princep. Our third family is going to be triazinone, common name hexazinone, trade name is going to be Velpar. Our next family is going to be uracil, with a common name of bromacil, trade name of Hyvar. Our next family is going to be urea, common name diuron, trade name of Carmex. And our final family is going to be urea, with a common name Tipithurian, trade name of Spike. These herbicides interrupt photosynthesis, the process by which green plants convert light energy into food. A little more on photosynthesis inhibitors. Control annual or perennial grasses or broadleaves. They shut down the photosynthetic process. They slow starvation of the plant. The plant experiences a more rapid death due to the production of secondary toxic substances. Injury symptoms include yellowing, chlorosis of leaf tissue, followed by death, necrosis of the tissue. Characteristics primarily absorbed through roots, but can also be taken up by leaves. Offer long-lasting control, beneficial in environments requiring consistent weed management. Triazines, group herbicides, are photosynthesis inhibitors. Photosynthesis inhibitors, divided into two types: mobile, slow-acting, soil-applied herbicide, pre- and post-emergence, and non-mobile, rapid-acting, foliar-applied herbicides post-emergence, both systemic. Triazines, triazinones, soil-applied, and nitriles, phenylperizidines, benzothiazinones, foliar application, are structurally diverse chemical groups but have similar MOA. These herbicides are effective primarily on annual broadleaves, selective, however at certain rates. Some provide control of grasses as well. Pigment inhibitors. Noflurazone, Solicam, is an example of a pigment inhibitor that affects carotenoid production. This leads to chlorophyll destruction and visible whitening of plant foliage. Pigment inhibitors are primarily used as pre-emergent treatments, preventing young plants from sustaining themselves, ultimately killing them. Pigment inhibitors. Pigment inhibitors cause white leaves in susceptible plants. New growth will not contain the green pigments needed for photosynthesis. Symptoms may be found on the cotyledon leaves and true leaves. White growth may be observed with veins, primarily with zorial, and between veins, primarily with command. Pigment inhibitor herbicides. We're going to talk about the family, the common name, and the trade name of some common pigment inhibitor herbicides. Family, isoxazolinone, common name, clomazone, trade name, command. Family, pyridazinone, common name, norflurazone, trade name, Solicam. Family, not classified, common name, fluridone, trade name, Sonar. These herbicides cause the green pigments, chlorophyll, in plants to be destroyed. Without chlorophyll, plants cannot photosynthesize and will die. Zorial, norflurazone, inhibit carotenoid formation, followed by loss of chlorophyll. New growth is white, sometimes tinged with pink or purple. Zorial usually follows the leaf veins. Characteristics, generally non-selective, and typically does not impact deeply rooted or well-established plants due to limited soil mobility. Cell membrane disruptors. Cell membrane disruptors such as diquat reward and glufosinate phenol cause rapid plant death by disrupting cell membranes, leading to the breakdown of cellular structures. These are primarily contact herbicides with no systemic action, meaning they only affect the parts of the plant they directly touch. Herbicide mode of action and classification. Cell membrane disruptors. Nonanic acid. Pelargonic acid, scythe. Post-emergence with no soil activity or uptake. Non-selective. Contact herbicide. Rapid foliar absorption. Non-systemic. Let's look at another chart of cell membrane disruptors. We're going to look at the family, common name, and trade name. We're going to look at our first family, Bipyridilliums. Common name is diquat, trade name is reward. Our next family, Bipyridilliums. Common name paraquat, trade name gramoxone. Our final family, diphenolethers. Common name lactofen, trade name is cobra. Destroy cell membranes, causing cell contents to leak out and result in desiccation of plant tissue. Let's look at some facts of a cell membrane disruptor. Post-emergent, contact herbicides, little soil activity, activated by exposure to sunlight to form oxygen compounds such as hydrogen peroxide. These oxygen compounds destroy plant tissue by rupturing plant cell membranes. Perennial weeds usually regrow because there is no herbicide movement to underground root or shoot systems. Characteristics. Injury symptoms appear quickly, often within hours of application for diquat. They are most effective on smaller or young plants requiring complete coverage for optimal results. Seedling root development inhibitors. Herbicides such as oryzalin, serflin, and pendimethalin, pendulum, inhibit root growth in young seedlings by disrupting cell division. These herbicides are mainly used for controlling grass seedlings as they prevent germination without affecting established plants. On the current image, you're seeing a little bit of what seedling root inhibitors do. Looking at root growth inhibitors, plant death generally occurs before emergence. Root inhibitors translocate very little, generally stable in upper soil profile. Persistence is herbicide dependent, most effective on small seeded grass and broadleaf weeds. Merisystemic root inhibitors, inhibition of cell division and the elongation of roots. Dinitroanilines, pendimethalin, Pendimax or Prowl, new H2O formulation, oryzalin, serflin, AS, trifluralin, Triflan or Trilin, pre-emergence with 1 to 3 months of soil activity, does not leach, Forms a herbicide barrier in clay soils. Apply before rainfall or shallowly incorporate. Controls grasses and small-seeded broadleaves, not translocated in plants. Herbicide mode of action and classification. Meristematic shoot inhibitors, strong inhibitor of mitosis, cell division. Chloracetamides or amides, nipropamide, devrinol. Pronamide, curb, apply post-harvest to 1-year-old vineyards. Pre and post-emergence with 1 to 3 months of soil activity, very little leaching, forms a herbicide barrier in clay soils, apply before rainfall or shallowly incorporate. Controls primarily grasses and small-seeded broadleaves, absorbed primarily by roots and readily translocated via the xylem. Environmental and plant factors influencing herbicide efficacy. Several environmental factors play a crucial role in herbicide efficacy, including precipitation, temperature, and sunlight. Our first factor we want to look a little further with is precipitation. Rainfall can significantly impact herbicide movement into the soil. If applied during or just before heavy rain, a herbicide may wash away or not penetrate the soil adequately, reducing its effectiveness. Conversely, dry conditions can hinder the performance of contact herbicides that require moisture for proper absorption. Let's think about it. With today's technology, you can see the forecast well in advance. Now, if you know you got a weather forecast like you're seeing here, where it's going to be very hot and dry for 7 to 10 days, you pretty much know you're in a different weather pattern than if you see something like this, where we're going to have a 100% chance of rain and cooler temperatures. As you can see, timing of herbicide applications is your responsibility as an applicator. Whether you're at a technician level, a certified supervisor, or a certified operator, you're the one making those decisions. You need to really watch the weather and think about what you're doing so you make correct applications at the correct time to make sure they're as effective and as safe as possible. Rainfall timing. Rainfall soon after application can wash away herbicides or dilute them, particularly for foliar absorbed products. Understanding the weather forecast before application is crucial for ensuring herbicide efficacy. It's no stretch of the imagination for somebody to understand you can't put herbicides out while it's raining or right after a rain and expect it not to wash away or be diluted. Those of you that have been in the industry for a while understand that temperature is important as well. Temperature influences herbicide activity and plant response. Most herbicides work best within specific temperature ranges. Extreme heat or cold can slow down plant growth and affect the absorption and translocation of the herbicide. Additionally, high temperatures can increase the volatility of certain herbicides, leading to off-target movement and unintended damage to surrounding vegetation. Soil types are another factor we need to be aware of. When we look at soil type, it also plays a critical role in herbicide absorption and persistence. Compacted, clay-rich soils often retain persistent herbicides longer than sandy, well-drained soils. The organic matter and pH of the soil can affect the herbicide's availability, influencing its efficacy. As you look at our wheel of soil types here, you can see there's a lot of different types like clay soils, loamy soils, peaty soils, saline soils, sandy soils, and even silt soils. And you may want to think back to what I showed a few slides ago where we talked about the weather forecast where it was going to be all bright sunny days. This can be a seasonal thing. In certain areas of the country, you get a lot of bright, powerful sunlight in the summertime, not so much in the fall, the spring, or even the winter. Whereas areas out west in the desert, you may have a lot more days that are sunny, and it doesn't really matter what time of the year because there's not a lot of cloudy days in places like Phoenix, Arizona. So just keep in mind you need to understand the impact the UV rays are going to have. You can even look at the UV forecast. If you go online, a lot of places you'll see a UV index forecast, That'll tell you what the UV light looks like over the next few days. Think about plant characteristics. Various plant characteristics affect herbicide absorption and efficacy. Leaf shape, surface texture, e.g. presence of hairs, and the location of growing points can all impact how well a herbicide is absorbed. For instance, leaf structure. The surface characteristics of leaves can significantly affect herbicide absorption. Plants with waxy or hairy leaves may hinder the penetration of foliar-absorbed herbicides, requiring higher application rates or alternative methods. Growth stage. The growth stage of the target plant plays a critical role in herbicide efficacy. Young, actively growing plants are generally more susceptible to herbicides. Conversely, mature plants may require higher doses for effective control, and certain herbicides may be less effective once a plant has reached the flowering or seeding stage. Let's talk about the life cycle of weeds. We're going to have three different types. We're going to have annuals, biennials, and perennials. With annuals, they complete their life cycle in a growing season, and they are spread by seed. With biennials, complete their life cycle in 2 growing seasons, reproduce by seed, rosette first year, flower and seed production during the second year, and finally perennials live 3 or more years, reproduce by seed, underground root structures, and/or plant cuttings. Something else we need to think about is root system depth. The depth and extent of a plant's root system can affect its susceptibility to root-absorbed herbicides. Shallow-rooted annuals may be more readily controlled with pre-emergent herbicides, while deep-rooted perennials may require systemic treatments to achieve adequate control. Take a few moments to review the root system depth of some common weeds. Natural defenses. Some plants possess natural defenses that can hinder herbicide absorption. For example, certain species may have thicker cuticles or trichomes that can reduce the effectiveness of foliar applications. Understanding these defenses can guide the choice of herbicide and application methods. Herbicide resistance. The repeated use of herbicides can lead to the development of herbicide-resistant plant species. Resistance occurs when a weed population no longer responds to a particular herbicide, posing a significant challenge for vegetation managers. This can happen through natural selection, where resistant individuals survive and reproduce, increasing the population of resistant weeds. Preventive strategies. To mitigate resistance, managers can implement various strategies, including rotating herbicides with different modes of action, using tank mixtures that combine multiple active ingredients, and integrating non-chemical control methods like mechanical removal or biological control. Regular scouting and rapid response to resistant weed populations are essential for preventing their spread. Maintaining accurate records of herbicide applications, including rates, timing, and targeted weeds, can help track the emergence of resistance in specific areas. Let's talk about the most important herbicide-resistant species. 1. We're going to have rigid ryegrass. 2. Wild oat. 3. Redroot pigweed. 4. Common lamb's quarters. 5. Green foxtail. 6. Barnyard grass. 7. Goosegrass. 8. Kochia. 9. Horseweed. 10. Smooth pigweed. Integrated vegetation management strategies. In vegetation management, herbicides are often part of a broader strategy that aims for comprehensive and sustainable weed control. This integrated approach combines chemical treatments with mechanical control methods such as mowing or manual removal, and biological methods such as introducing natural weed predators. Benefits of integrated management. 1. Reduced herbicide dependency. By incorporating mechanical and biological methods, managers can reduce their reliance on herbicides, minimizing the risk of resistance development. 2. Enhanced ecosystem health. Diverse management practices can promote biodiversity and improve soil health, supporting the overall ecosystem. 3. Cost efficiency. Combining methods can lead to long-term cost savings by reducing the need for frequent herbicide applications. Let's review a little bit about what we're talking here. When we think about reduced herbicide dependency, that's a really big deal. Obviously, you can imagine when we're using less herbicides, we're going to have less impact on the environment. You can see the photo of the green globe here. The reality is we need to incorporate more of these mechanical and biological methods so that we can reduce the reliance on herbicides. Anytime you're putting out an herbicide, you know at some point it's probably going to get carried away from that target site, at least to a point. Now granted, we're watching the weather, we're watching the wind, we're trying to make sure that we're not putting these products out on a day where it's going to rain or obviously while it's raining. But the reality is, at some point, you still have to think that some of this can get into nearby waterways or non-target areas. We also need to look at minimizing the risk of resistance development. So as you know, when you use the same products over and over again, there's always going to be a risk of resistance. So make sure you're rotating your products. Don't use the same products with the same modes of action over and over again. But again, we need to lower our reliance on these herbicides. It's only going to be better for the environment, also better for you as a company with cost savings and things like that, which we'll talk about here in just a moment. Just looking at topic number 2 on our list here, the enhanced ecosystem health. So again, we have to look at these diverse management practices because we're trying to promote biodiversity and improve soil health. So one of the things we want to do is we don't want to kill non-target organisms, whatever the case may be. A lot of times these non-target organisms are actually healthy and good for the environment. And also we need to look at overall soil health. So the soil itself is very important. And as we put down herbicides and do things like that, it can have an impact on the soil health. The bottom line is we want a good overall healthy ecosystem where the good plants are growing and we're taking out the ones that we don't want there. Now, as I mentioned before on number 3, cost efficiency, I just want to tell you this combining of methods and not just relying on herbicides is really a big thing when we look at cost efficiency. I can't think of anybody who's not cost conscious nowadays. So the reality is when we're using a lot of expensive herbicides and we're having to put in the man hours, buy the products, the labor, when you look at it, there's a lot of costs with this. So we really need to think about how frequently we need to do these herbicide applications by combining these other methods that can help us not have to do that. The reality is companies, whomever's paying for these services, they don't want to pay a lot of money. So how can we reduce the amount of times we have to put out the herbicides, ultimately saving them money? So what I'm looking at when I say this is the fact that we can lower our use of herbicides, we can combine these other methods, and in the end we can save time and money, which is something every business is looking at in today's environment. Integration of IPM strategies in weed management. 1. Utility rights-of-way management. In utility corridors, managers often use a combination of herbicides and mowing. By initially applying systemic herbicides to control woody vegetation, followed by periodic mowing, they can manage regrowth effectively while minimizing chemical use. 2. Forest management. In forestry, integrated approaches often involve using pre-emergent herbicides combined with prescribed burns. The herbicides control competing vegetation, while controlled burns promote the growth of desirable species. 3. Urban areas. In urban landscapes, herbicides can be used alongside manual weeding and mulch applications to control weeds along road shoulders and around trees. This integrated approach maintains aesthetic appeal while ensuring healthy plant growth. And here we go again looking at a combination of techniques to control weeds. Now, obviously, manual weeding, again, I think is something that can be done, but also there's a cost to that. And then putting down things like mulch can even be great because at that point, we're choking the weeds out. We're not allowing them to grow. But one thing these two methods definitely do, they do lower the need for herbicide applications. And no matter how we look at it, the herbicide applications themselves, as I keep saying, are going to be the most expensive, labor intensive, and ultimately have the largest negative impact on the environment. Native flora. Strategy. They utilized a combination of pre-emergent herbicides and prescribed burns. Herbicides were applied to target invasive species prior to a controlled burn, enhancing the effectiveness of both strategies. Outcome. This integrated approach improved the health of the forest ecosystem with a noticeable resurgence of native plants in the years following treatment. Regular monitoring ensured that the invasive species were kept in check. Explaining right-of-way herbicidal vegetation management program. A lot of times when you're doing herbicidal right-of-way vegetation management, it's important that you explain the program. Let's take, for instance, you're working with a utility company. You might want to put something out like a service announcement that talks about what you're doing and why you're doing it. Something like, we're going to be doing some right-of-way treatments that are going to help with the reduction in encroachments by woody stemmed vegetation on electric distribution lines, potentially leading to reduced numbers and frequency of outages and improved electrical service reliabilities for members. When we think about putting notes like that out, what it really does is it explains to your customers what you're doing and why you're doing it, so you don't have to worry about what people are thinking during that process. Pesticide sensitivity has become a real issue. A lot of states you work in, you're going to see a list of people that are chemically sensitive to pesticides. A lot of times you even have a registry of notification where you have to notify certain people before you can put out a pesticide or an herbicide. So we need to be aware of the fact that people are super conscious to the applications of herbicides and pesticides, and we need to think about it before we do the applications, that we notify people, but also put out there why we're doing it, and then notify the people on these registry lists, because the worst thing that can happen to you is somebody lives on a piece of land that's close to your application area, and then they notice you're putting an herbicide out. Next thing you get is a call from the state, and they're asking if the person was notified, and you can't prove that they were. I've seen this happen, and this can cause a lot of issues, and it can even lead to state fines and violations. For effective weed management. By incorporating environmental factors and integrating herbicide use with mechanical and biological methods, vegetation managers can develop sustainable strategies that minimize herbicide resistance and promote healthy ecosystems. As vegetation management continues to evolve, the ongoing research into new herbicide formulations and alternative control methods will contribute to more effective and environmentally responsible practices. The application of herbicides will remain an important tool, provided it is used thoughtfully with an integrated vegetation management framework. I want to leave you with this. You need to be conscientious, you need to protect yourself, and always consider the environment when choosing to make any herbicide application. You and I are the people out there on the front lines. We're the ones making the decisions on when to use an herbicide, where to use an herbicide, and how to use an herbicide. No matter what position you're at in a company or in your organization, when you have that equipment in your hand, you're deciding on how that application's made. So make sure to be conscientious, make sure to make it at the right timing, and make sure our ultimate focus is protecting the environment around us. The use of trade names in this publication is solely for the purpose of providing specific information or as examples. American Pest CEUs does not guarantee or warranty the products named, and references to them in this publication do not signify our approval to the exclusion of other products of suitable composition. All chemicals should be used in accordance with directions on the manufacturer's label. Use pesticide safely. Read and follow directions on the manufacturer's label. Thank you for choosing us. We would appreciate any comments you may have about the course. Please send us an email to pestceus@gmail.com. You are now ready to proceed to the exam. Once completed, you will receive your certificate.